Example 2. Prove by mathematical induction 10 to the power of 2n minus 1 plus 1 is divisible by 11. So, while proving by mathematical induction, I consider the statement for n is equals to 1, Pn as 10 power 2n minus 1 plus 1 is divisible by 11. So the first process is we have to prove the statement is true for n is equals to 1. So I consider for n is equals to 1, 10 to the power of 2n minus 1 value. N equals to 2n minus 1 plus 1. N equals to 1, substituting it, you'll be getting 10 to the power of 1 plus 1, which is 11 and is divisible by 11. That implies 10 to the power of 2n minus 1 plus 1. You got it as 11. So E is divisible. So E is divisible by 11. It implies P1 is true. That means the statement is true for n is equals to 1. Now let me assume the statement is true for n is equals to k. Let p k be true. Let p k be true. That implies 10 to the power of 2k minus 1 plus 1 is divisible by. So is divisible by 11. So that implies 10 to the power of 2k minus 1 plus 1 is equals to 11 times of an integer m. 11m. So m belongs to integer. So that implies 10 to the power of 2k minus 1 can be written as 11m minus 1. So call this as a condition 1. Now I have to prove. So to prove statement for k plus 1 is true, it implies 10 to the power of 2 times k plus 1 minus 1 plus 1 is divisible. So is divisible by 11. The number is divisible by 11. We have to prove it. So consider 10 to the power of 2 times k plus 1 minus 1 plus 1. That is can be written as 10 to the power of 2k plus 2 minus 1 plus 1. That can be written as 10 to the power of 2k minus 1 into 10 square plus 1. So the exponent 2 make it separate. So why should I write like this one? Means I need to use from the condition 1. 10 to the power of 2k minus 1. For that sake, I am separating exponent 2. I mean 10 power 2 separate. So that from condition 1, 10 to the power of 2k minus 1 can be replaced from here by 11m minus 1 into 10 square plus 1. And that is equals to, that can be written as 11m times of 10 square, that is 100, and minus 1 into 100, 100 plus 1, minus 100 plus 1. Minus 100 plus 1 is minus 99, which can be written as 11 into 9, 11m. So you can take out 11 common. 11 into 100 times m minus 9. So we got an integer multiple of 11. So it is divisible by 11. So LHS value is divisible by 11, multiple of 11. So that implies that 10 to the power of 2 times k plus 1 minus 1 plus 1, the number is divisible. So it is divisible by 11. So that implies p k plus 1 is true. That means statement is true. Therefore Pn is true. Pn is true for all n belongs to capital N. For all n belongs to capital N by mathematical induction. By mathematical induction. Right? Hence the proof.